class. Today we're going to talk about sequences and series. Sequences. We'll do a series at another point. So let's talk about two different types of sequences that you're likely to see. Okay, one of them is called an arithmetic sequence. And what defines an arithmetic sequence is that there's something like you consistently add to get from term to term to term. Okay, so let's take an example. During the quarantine, let's say the first day I make a resolution that I'm gonna do push-ups every day, but let's say the first day I can only do 7 push-ups. And then let's say after that, I aim to do 3 more push-ups every single day. Okay, so if I do that, the next day I'm gonna do 10 push-ups, and the next day I'm gonna do 13 push-ups, right? And then the next day I'm gonna do 16 push-ups, and so forth. Okay, so what you can do to really verify that something like that is an arithmetic sequence is you can take like a later term minus the one just before, okay? So I could do 16 minus 13, and of course that's 3. Or I can do 13 minus 10, of course that's 3. So what it's called is the common difference, okay? And they'll often call that D. Okay, so in this case, D would equal 3. That would be my common difference. Okay, let's come up with a definition for this kind of sequence. And there's actually 2 definition types that I want you to be familiar with. Okay, so one of the definitions is going to look as follows. Okay, so it's going to look like A sub n. Okay, now this one is going to be a little bit, let's see if you can figure it out. Okay, so let's try to test this definition out and see like how it works. Okay, so if I plug in, if I want to find the first term, I want to find A1. So A1 is going to be 7 plus 3 times 1 minus 1. Okay, so in this A1 would just be 7. Okay, and if I go back to my definition up here, that would be like my A1. Okay, this would be A1, A2, A3, A4, like that. Okay, so A1 is 7. Okay, let's say I want to use this definition. Okay, so I use that to find A2. A2 would be 7 plus 3, and then I need to plug in 2 where the n is. That's going to be 7 plus 3 times 1. Okay, and so that's just going to be 10, which really is the second thing in the sequence. Okay, so you get that this definition that I wrote up top here is like a definition that's going to generate that sequence for us. Okay, so that definition is called what's called an explicit definition. I'm going to write that, explicit. It means that it just jumps and gets you right to the definition that you, or to the term that you want to find. Okay, so what's nice about an explicit definition that works is that I can actually plug in a number like 100. Okay, let's say I find the 100th term, and I can immediately jump to it. Okay, so I want you to contrast this with another type of definition, which is called a recursive definition. So the way a recursive definition works is that a recursive definition generates things from the previous term. Okay, so let's write that here, recursive. Okay. So a recursive one, I could go ahead and say A1 is 7. Remember, I starting day 1 with 7 push-ups. And then I want to define the next one in terms of previous ones. So then I need a starter, though, for this one. A1 is 7. And then I could say each one is the previous one. So each term is given by the previous one plus 3. Okay, so the upside of this kind of definition is it really kind of leads you from how to get from one term to another term, that sort of thing. But the downside of this, if I want to find like the 1000th term, it's not a very easy definition. I mean, I can find the 1000th term, right, only if I had a 999, then I know that like I could take the 999th term and then add 3 and then get the 1000th term, but it doesn't immediately jump you to that. So recursive definitions are nice at times, but other times they're less useful.